be looking at how matrices can be used in addition problems, subtraction problems, multiplication problems. Matrix operations are only defined for addition, subtraction, and multiplication. We do not have the ability to do division problems of matrices. So some of the application-based problems in there on the matrix applications, which is not due until Monday for us, will show you a place that a business might use a matrix as opposed to doing things by hand, okay? So definitions again, some of which we saw from the last unit. Some of the questions in here will talk about this. A matrix is a rectangular arrangement called an array of numbers written inside of brackets. The size of a matrix, that's important in this section because there are certain restrictions for addition, subtraction, and there are certain restrictions for multiplication. And it's tied to the size of the matrix, so we got to be careful about making sure we recognize the language of matrices are defined by how many rows they have, up and down first, and then how many columns they have, left and right, okay? Square matrix, same number of rows as columns. Column matrix has only one column in it. A row matrix has only one row in it. Principal diagonal, from the upper left-hand corner to the bottom right-hand corner. Principal diagonal is only appropriate when you have a square matrix. In an augmented matrix, we don't have, and we have an extra column, but the principal diagonal carries all the one values for the variables in the exercise. Matrices are equal only when all of the corresponding elements are equal, and that means they have to have the same size. And a zero matrix has 0 for all of its elements. So a little bit of vocabulary-based stuff in there. Okay, so if that's the case, we start off with the simplest operation first, a scalar product. A scalar product means that we're not multiplying two matrices together, we're multiplying one number across the entire contents of a matrix. A scalar product is very reminiscent of the distributive property. Every value in a distributive property, if you get an exercise that looks like this, is this a typical distributive property for us? If we were distributing there, what would we do with that 3? By how many terms? Every one of the terms there, right? So would 3 be multiplied by 2x? Giving us 6x. Would 3 be multiplied by 4y? Would 3 be multiplied by 1z? Would 3 be multiplied by 8? So a scalar multiplication problem is nothing more than a distributive operation. That's all it amounts to. If we were asked to do this multiplication problem, and you will not always see a multiplication symbol in front of here, because we know that when we put a variable in front of a grouping symbol, or a variable in front of a variable, that implies multiplication. So with or without, and that means on your calculator too, with or without, it's still going to mean a multiplication problem. Good news, yes, we can do all these things on the calculator if we want to. Bad news, test is going to ask you to do a couple problems by hand. And if you don't show me steps you're going through by hand, right or wrong, you're losing all the points. So if this was a scalar multiplication showed up on a test, this is what I would expect to see as your support work for the problem. 3 is going to be multiplied by 4. 3 is going to be multiplied by 2. 3 is going to be multiplied by -3, by -1, by 3, and by 5. Your support step, your intermediate or middle step, would look something like this. Put it down on paper, whether they ask or not, because even though you're saying, well, I'm going to put it into the calculator, if you show me what your intentions are, and you mistype something, you get points for having a good plan. You lose points for not being able to execute your plan. Okay, but this would be what we would be looking for in the problem. So if that's the case, then how difficult would it be to do -2 times a? Well, that would look by hand like this. And your support step, your middle step for that problem then, would look like this. -2 is going to be multiplied by 6. Negative 2 is going to be multiplied by negative 1. Negative 2 is going to be multiplied by 5. Negative 2 is going to be multiplied by negative 3. Negative 2 is going to be multiplied by 0. Negative 2 is going to be multiplied by a positive 2. Meaning that your end results of the problem, when you're finished, you're going to have a matrix that still has 3 rows and still has 2 columns. What will be the value in the upper left-hand cell?
12.
Negative 12. Upper right-hand cell?
2.
Positive 2. Middle left-hand cell?
10.
Middle right-hand cell? Don't whisper. Lower left-hand cell? Lower right-hand cell? Negative 4. This is your support step, your middle step, your intermediate step. And if it asks you to do that scalar multiplication and show support by including the specific steps or the intermediate step or the middle step, they mean by hand. If you don't show me the support by hand, and that's an 8-point problem, then you're losing those 8 points whether you got it right or not. I have had students that have been stubborn before and have taken test 4 and have walked out of the test with a 100%, and when I get done looking at partial credit, they have a grade of 60. Because on the test, there are 3 questions that say, do this by hand. And if you don't do it by hand, well, that was 12 points that went away, and then there was another 12 problem that point went away, and then there was another problem that went away. You lose points by not following instructions. Now, I know that's tedious, but that's not a difficult operation to be able to do. You can almost write that as you're, almost do it as you're thinking about it. Could I do it in the calculator? Absolutely. Not a problem whatsoever. All I have to do is get the information in the calculator. Oh, wait a second. We know how to put matrices into a calculator, don't we? So if I'm going to do this problem with the calculator, I simply need to change the way that I look at the problem. I simply need to change what I'm going to do with the problem. Now I'm not using a built-in program to do something for me. I'm telling the calculator, do what I want you to do. Will I still go into the matrix menu? Will I still have to adjust or put in the information for my matrix into one of these places? Can I reuse one that's already there? So I don't need to create a whole table full of matrices out there because you'll forget what's where. So I go to the edit and I come back and say, I don't think I want a 2 by 3 this time. I want a matrix that is 3 by 2. Does that look like it's the right setup? See, so it makes it almost difficult, almost impossible for you to make a mistake, but some people are not foolproof and they can make a mistake. So now ingredients, 6, negative 1, 5, negative 3, 0, 2. Matrix is in. Am I going to be doing any more editing on the matrix? No. Then go back to the home screen. Now, what did you want to do? I wanted to multiply 3 by matrix number 1. Do those numbers look familiar? Oh, because I didn't want to do 3 times that, did I? I wanted to do 2 times that, didn't I? My bad. I can fix that real easily. I don't have to go all the way over and do it by hand. Does that look better?
No.
Oh, it's supposed to be a negative 2. Oh, doggone. I keep making mistakes. I don't do these things on purpose. Just like you don't do them on purpose, but it kills you on the test when you make the simple mistakes. So, negative 2. Does that look better? There we go. Now we finally got it right. I could have done that one by hand. I could have done that with the calculator. Do I have to do it by hand? On the test, if it says do it by hand, by God, do it by hand. Quit giving away points because there's new and more interesting mistakes to make than repeating the same mistakes that are sitting out there. Now, can I write that differently? Could I say that I wanted to do matrix A, and I wanted to multiply that by a -2? So multiplication, as long as you're doing scalar, doesn't make a difference if we put it in front or we put it in back, although we're most likely, we usually see distributing probably with the number in front that we want to distribute, right? Okay, so we can do that with the calculator if we wanted to. Scalar multiplication, walk in the park, should not make that mistake ever. Okay? Addition of matrices, question first.
I just was wondering how you put that 8 like right there so quick.
Okay, so matrix, and look what column I'm in. I'm in the name column. The only time I'm ever in the name column is when I want to point the calculator to a matrix and says, use this. So which matrix do I want to use? The matrix A, which is the one that's already highlighted there, so just entering.
Can you do it like without going to the menu?
Nope.
Okay.
Nope, you can't type it in by hand. There's no other way to do it than to go through the menu to be able to get there. There is no way for you to do a bracket. There aren't even any bracket grouping symbols. There are parentheses, but parentheses don't mean the same thing to the calculator as a bracket does. There are braces, but braces don't mean the same thing. I don't see any other symbol on the screen of this calculator which looks like a bracket anywhere at all. So no, you cannot type it by hand. You have to go through the menu that picks up that specific notation. Okay? So,